For the first time, both the Hubble Space Telescope and the James Webb Space Telescope are trained on the same interstellar visitor, 3I/ATLAS. Not just one, but our two most powerful observatories are capturing it in visible ultraviolet and deep infrared light. Two perspectives, two instrument suites, one target, Hubble, orbiting just above Earth, is mapping its coma, the vast cloud of gas and dust streaming from the nucleus. James Webb, 1,000,000 miles away, is dissecting its spectrum, reading the chemical fingerprints encoded in its light. Fingerprints. This is unprecedented. No interstellar object has ever been studied like this under the simultaneous gaze of humanity's sharpest observatories. And there's a reason both are watching. Hubble and Webb rarely share a target. Their time is too valuable and their missions too different. But 3I/ATLAS is no ordinary object. Hubble, with its sharp visible and ultraviolet vision, is tracking the coma, the glowing halo of gas and dust that envelops the solid nucleus. On July 21, 2025, it delivered its clearest view yet, a faint, ghostly shell stretching tens of thousands of kilometers, hiding a nucleus only a few kilometers across. From these images, scientists can estimate how fast the object is shedding material, about 6 to 60 kilograms per second, depending on particle size, roughly a car's weight disappearing into space every minute. Meanwhile, 1,000,000 miles away, the James Webb Space Telescope is observing it in the infrared. What Hubble cannot. The chemical fingerprint of this interstellar traveler. Webb's infrared vision has confirmed water ice, carbon-rich dust, silicates, and complex organics, molecules that may have been frozen in place for over 7 billion years. Together, they're giving us something unprecedented, a full spectrum profile of an object born around another star, its composition, activity, and behavior, documented in extraordinary detail. From the first combined data sets of in the Hubble and Webb observations, something subtle stood out. Not a single dramatic anomaly, but a pattern of small details that don't quite add up when taken together. The first surprise was in the coma. Typically, solar radiation drives gas and dust away from the sun, creating a tail that points the other direction. 3I/ATLAS isn't strictly following that rule. Part of its dust stream appears to angle toward the sun. That's not impossible, just unusual, suggesting the particles are heavier and larger than typical comet dust and less easily pushed by sunlight. Something in its composition is resisting that force. Then came the spectral data. Webb detected water ice expected for a comet, but also a complex mix of carbon-rich compounds and silicates. These aren't strange by themselves. What's strange is their state. They appear almost untouched by time, as if locked away from heat and radiation for billions of years. Some of these molecules could predate the sun by hundreds of millions of years. Hubble's imaging adds another layer. The coma is brighter than models predicted, but the nucleus is smaller than expected for such activity. That mismatch forces scientists to ask, is the brightness coming from something other than just reflected sunlight? Could the surface be unusually reflective? Or is there a process we don't yet understand at work here? And then there's the trajectory. While retrograde, moving opposite to the planets, it's only 5 degrees off the ecliptic plane. That's rare. Most interstellar visitors arrive on steep, random-looking trajectories. But 3I/ATLAS is nearly coplanar with the planets, almost as if it entered along the same corridor we use to send probes to the outer solar system. Some chalk that up to coincidence. Others cite Avi Loeb's argument that the sequence of planetary flybys, Venus, Mars, Jupiter, has only about a 1 in 20,000 chance of occurring by chance. That doesn't prove intent, but it does prompt the question: could the unusual tail orientation, pristine material, bright yet small nucleus, and improbably precise path all be unrelated? Maybe, or maybe, they're the fingerprints of something we haven't seen before. Either a natural process we don't yet understand or something deliberately engineered. For now, the Webb and Hubble teams are still collecting and processing data, but one thing is already clear. 3I/ATLAS isn't behaving like an ordinary comet. Every observation raises a new question. Each answer seems to spawn 2 new questions, and soon the chance to tackle them will vanish. Literally. Time is the one thing the Hubble and Webb teams don't have. 3I/ATLAS is racing along at nearly 60 kilometers per second, and in just a few weeks it will slip behind the sun from Earth's perspective. For ground-based observatories, that means a total blackout. For Hubble, the glare will be blinding. Even Webb, stationed far beyond the Moon's orbit, must respect strict pointing limits to protect its optics. That blackout will occur at perihelion, its closest approach to the Sun, exactly when its activity is likely to peak. As heat penetrates the outer layers, buried ices could sublimate violently, ejecting fresh material from deep within. Each outburst might expose minerals untouched since before our sun was born, and we may not see it happen. A cosmic paradox. The moment of greatest revelation is also the moment of greatest invisibility. There are, however, other eyes in the solar system, not currently aimed at 3I/ATLAS, but close enough to pivot. ESA's JUICE spacecraft, bound for Jupiter's icy moons, will come within about 0.3 astronomical units of the comet during part of this window. NASA's Psyche probe, en route to a metal-rich asteroid, will pass at a comparable distance. At those ranges, even a modest camera could capture details impossible to see from Earth. But there's a catch. Retasking these missions would burn propellant reserved for their primaries, rewrite navigation plans, and ask teams to take a risk on an object that officially poses no threat. In deep space, every kilogram of fuel is survival. Every course change is a gamble. The most ambitious idea on the table is to use NASA's Juno, currently orbiting Jupiter, to attempt a flyby of 3I/Atlas in early 2026. Proposed by Avi Loeb and collaborators, the plan would have Juno slingshot around Jupiter for a major boost, potentially bringing it within range as the object leaves the inner solar system. On paper, the numbers work. In reality, Juno's main engine has issues, and its remaining fuel may not be enough for such a precise maneuver. Some call it a brilliant reuse of existing hardware, others a reckless fantasy. But everyone agrees on one thing. If it could be done, it would yield our first close-up view of an interstellar visitor. That's why the pressure is mounting. Because this isn't just another comet passing by. This is a piece of another star system, a messenger from a place we may never reach. And if it carries secrets we've never seen before, this might be our only shot to uncover them. In a few months, it will slip away. Its coma will dim, its spectrum will fade into the background noise of space, and it will become just another moving point shrinking into invisibility until even the best telescopes in the world lose it. Once it's gone, there will be no going after it, no second chance. It's a race against celestial mechanics, against the sun itself, against the quiet indifference of the universe. And the clock is still ticking. Soon, 3 Atlas will vanish from our skies. It will swing behind the sun, hidden in its glare, and when it reemerges, it will already be on its way out. Fainter, faster, slipping beyond the reach of even our sharpest instruments. A brief visitor from another star system, passing silently through our own and then gone. What Hubble and Webb are gathering right now. The images, the spectra, the numbers will be the record we keep for the rest of human history. Every pixel, every spike in the data will be studied for decades. And yet, even with all this, the truth may remain just beyond our grasp. Maybe it is exactly what the cautious voices say. A comet, nothing more, nothing less. Ancient, yes, from far away, yes, but still just ice and rock, following the laws of physics and chance. Or perhaps hidden in the play of light and shadow is something we don't yet know how to recognize, a deviation too subtle for an untrained eye, a message written in dust, a path that was never truly random. It could take years, even decades, before someone spots the anomaly that changes everything. And when that moment comes, it will be too late to look again. Space offers no rewind. The thought is humbling and a little terrifying. A fragment of another world sits within reach. And we're training everything we have on it, not just to understand it, but to understand ourselves. Another interstellar traveler will come, whether in years or in centuries. When it does, we'll remember this moment. The first time humanity's 2 greatest eyes worked in concert, not on a distant galaxy, but on a single speck crossing our own cosmic neighborhood. If you want to be here for the next arrival, subscribe, leave a signal.